Hello, welcome back to Math Time with Professor Prime. I'm your host as always, Professor Prime. Let's talk about math and cartoons. So, when it comes to cartoons, right? We're dealing with animation, right? And right off the back, we're dealing with animation, we're dealing with shapes, right? We're dealing with motion or the illusion of it. And either case, we're dealing with math because those things are inherently mathematical. And what's cool about cartoons, what's cool about animation as a whole, is that, it's this unique way of storytelling. And I think that's cool. And there's so many genres that fit in, right? Because you could have something that's comedic in nature. You could have something that's action packed, something that's a drama. You could have something that's like cribbing from one genre and using it in another to convey some sort of message. And no matter how you cut it, right? There's math in it all. And there's just so many cartoons, that come to mind for me, for my background. Um, and while you get a lot from the Western side of things, you find cartoons everywhere, and you find like that the history goes back quite a while, while. Because right, even before cartoons in a traditional sense, right, there are ways that we associated drawings with movement, and getting across that to people in different ways is an effective way of storytelling, among other things. And so, yeah. So let's talk about more of the ways that cartoons employ math. So like I said, to start, right, we're dealing with shapes, we're dealing with motion. And when it comes to those shapes, right, we're dealing with different character designs, we're dealing with different objects in that world and how those characters compare to each other and compare to that world. So, we're dealing with ratios, we're dealing with proportions, we're dealing with scaling, we're dealing with a lot of geometry across the board. And when it comes to motion or getting that across, right, there's so many tricks that you can play that get across. The idea of motion and the idea of speed, right? There's different angles that you can work with, different positions, different tricks with the line work. There's ways that you can compare characters to one another, right? To get that idea of speed across, right? Because you could have someone just, standing relatively still while other characters are coming at them really quickly, and they're blocking or dodging or they're barely moving, and that could be an indicator of their speed. And on the flip side, you can have the character that's supposed to be moving fast actually moving fast, and the other characters are moving slow, or they're having a problem to like keep up. You might be dealing with like different like motion lines, or like characters in different positions at the same time on the screen to indicate it, like someone like dodging a punch. Maybe they're like, and you see that through the animation. But no matter how you cut it, right? There's math in all those things. There's math in the coloring. There's math in the lighting. There's math in the initial drawings that leads to the animation. There's math in the storyboarding. If there's comedy involved, there's math in that too. Because if you have comedy, right, the idea is there's a basic formula for a joke, right? You have setup plus punchline equals joke, and there's different ways that you can play with that, right? Not only in the jokes that you tell, but being able to visualize those jokes. There's things that you could play with that in math along the way. Um, and then you got to figure there's this math in the production of a cartoon in general, right? Like there's math in the money that it takes, the money that it'll make, the different products that it could also be tied to. There's math in the storyboarding, math in the actual drawing, math in the animation itself. um, Sorry, it was in my head. Music. There's math in the music. It's not uncommon for some cartoons to have like a theme song, and there's math in how that's composed and trying to make that iconic. Math in the notes, math in how those notes are strung together, math in the motifs that come along with that, math in the timing of that too, and how long, let's say, like an opening song lasts. So I feel like it's fascinating too, because if you're dealing with a cartoon opening, not only is it something that you're snipping together these images, and you're making a title and you have this song and there's math and all that, but you got to figure it's part of the episode, right? It takes up time. And so if you have like something that's a 22-minute show, but it's in a half-hour block, um, you can save yourself some time because there's going to be commercials, but within that 22 minutes you're like, oh well, maybe we have this opening, maybe we have this ending. You do something to make it memorable, which again, math involved in that, and then fill in the rest. And not only why will you have something like the traditional 22 minutes, but you could have like a series of shorts, right? And there's math in determining how all this works, how it functions, and it flows. And animation has had such a rich history and led to so many things. And you got to figure, right? You might have cartoon adaptations of different properties out there. Like maybe I get a cartoon based on a video game or a comic or something like that, um, or vice versa. Sorry, I jumbled this in my head. But what I want to say is that you have cartoons that lead to adaptations and different media like video games and movies that could lead to cartoons. And no matter what you're talking about, there's math involved. And I think that's really cool. And with my experience with cartoons, I can't even remember when I first saw one. I just know it's been most of my life, right? That I've been watching like some sort of animation. And whether we're talking about Western or Eastern cartoons, I've seen a lot. And, and I say like Eastern cartoons, uh, I think anime and a lot of people don't like those things grouped together, but I guess like a more simple approach is to say like Western animation, Eastern animations, whatever. It's all the same in one form or another, and yet very different. And I think that's fascinating, and just watching things interact with each other too. And I remember growing up, I watched a lot of different things, right? Like I grew up watching X-Men and Spider-Man, Batman animated series, Superman, Fantastic Four, Incredible Hulk. Um, I was trying to say Hulk, but I think it came on like Hawk. But anyway, oh yeah, Iron Man, stuff like that. Like so, a lot of comic book stuff. But I also remember watching things like Looney Tunes, Tiny Toon Adventures, Eek the Cat. That was a thing. I remember that. Mighty Max, stuff like that. And at the same time, like back then, there's like animated features that or anime that have that Japanese origin that I didn't know at the time, right? Because I watched like Ronin Wars, aka Samurai Troopers, Voltron, Transformers. Um, I'm sorry, Speed Racer, stuff like that. And all like around the same time. So it's just I was getting exposed to Western animation and Eastern animation, and then like throughout the years, not just things that are focused on like America or Japan, but just like all across the world. And I think it's all cool because no matter how you cut it, right, there's math along the way, and I think that's really cool. And one of the other things I wanted to say is like, so we talked about a lot of things, but I also want to talk about how there's math in voice acting, right? Which is awesome because not only, or sorry, is there math in dealing with like how um, a character will sound, right? Because there's math in how a character's voice is pitched. There's math in how loud a character is talking at different intervals, right? There's math in the breathing, math in the timing of a line, math, and so many other elements of sound that go into voice acting. And you are acting with your body, whether you realize it or not, if you're doing voice acting. And there's math in how all that functions and how all that flows. And math and money across the board, right? Like how much everyone is getting paid, or not getting paid in some cases, and they should get paid. But there's math across the board, and I think that's interesting. And I never really fell off from cartoons. I'm a big fan of that. Big fan of anime. Big fan of just animation in general. And I made a whole video on that too. And it's just like there's also something to consider is like I grew up predominantly on 2D animation, but 3D animation has become more of a thing over the years. And what I find interesting about that is like not only is there like math inherent in those concepts, but I think even before a lot of us knew it, if we didn't see what we consider to be like 3D animation right off the top, we probably saw it before we saw it that way. And I say that because like over time, you know, there's been a lot of animation that was like 3D that's kind of gotten woven into things, and I think that's cool if done right. But no matter how you cut it, right? If we're dealing with comedy, we're dealing with horror, we're dealing with action, we're dealing with some sort of adaptation. There's just like this math across the board with cartoons, and I find that fascinating. And with that idea of cartoons, I have been rewatching like the Boondocks, and it's like so much of it is still very much funny. Um, and I can respect that, and I think that's interesting because, like, for several reasons. Like, one, I grew up reading a comic strip, and then just seeing it to become, a cartoon was really cool. And also just like watching it and being a big fan of anime, it's like, holy crap, is it inspired by that? Like so many animation choices, if that makes sense, right? And I think that's cool. But I've also watched so many other things over the years, and I got to talk to a friend recently who I didn't really know was into that stuff as well. And so that was an awesome conversation. It was really cool. But yeah, so that's all I have to kind of say for this video. I'll see you in the future. Professor Prime out.